Okay, one of the last things you're going to do after you assemble your transmission, or as you're assembling your transmission, you're going to go ahead and press the hubs on, assemble the gears and the blocker rings in their correct order, and then what you're going to do is you're going to measure this gap right here. This is the end gap. You want to go ahead and put a little pressure on that, slide it over, go in there with a feeler gauge and measure it. Now, unlike most of the specifications, up to this point in our classes, as things got worn out, the clearances would increase. In this particular example, as this wears out, this clearance will actually decrease. So be aware of that as this material wears, it's going to slide further onto the speed gear, causing this gap to be tighter. So that's really all you're going to do. You're going to do that with a feeler gauge. Just put a little pressure on it, measure that with a feeler gauge, whatever the gap that is. If it is wide, it's going to need to be replaced. Because remember, if this wears out, we're not going to clock correctly, so we're going to have clash. We're going to have the sleeve itself, okay, trying to mesh on the speed gear, and it's going to cause a clash. So if you've got a vehicle, typically the second gear synchronizer is the one that wears out the worst. And the reason for that is as you drive a vehicle, you put the vehicle in first gear at 0 miles an hour. So in that case, nothing's really spinning other than the spin down in the input shaft maybe a little bit. But there's very little spinning in the transmission. So once you put it in gear, it's very easy to put in gear. Once you upshift 1 to 2, that is going to be the widest ratio shift. So the difference from first gear to second gear is a significant ratio difference. So in that particular case, that's usually the blocker ring that wears the most. Once you get the third gear, fourth gear, fifth gear, and you continue up through your shifting, you're going to find that gear ratios become a little tighter, a little closer. So the closer the ratio is, the less likely you're going to burn out a blocker ring. So that's really what's going on here. That's the theory of the blocker ring and the synchronizer assembly. So if you go through your book and look at some of the illustrations, this is another breakdown, a slightly different type of a puck assembly that retains this. Again, as the sleeve slides over the hub, it's going to push these three little tabs, these three little pucks, against the three little tabs on the inside of the blocker ring, these three little pockets, and then it's going to go and push that into the speed gear. Once the speed gear gets up to speed, the blocker ring will move out of position, allow the sleeve to continue to slide over the speed gear and fully engage the speed gear. It's called clocking. It's very well described in the book. There's some illustrations at the top of here. They don't really do much for me because it's it's a little tough to see something when it's cut in half. But that's your blocker ring operation. Another thing I want to point out to you, this is something I've seen for years and never really focused on, was the little angular cuts in the sleeve itself. These angular cuts in the sleeve, and you can actually see them. I don't know if you can see them on the video or not, but you can see these slight angular cuts. I call them the diamond-shaped cut that's on the sleeve teeth itself, will correspond with the same pattern on the actual speed gear. So if you look at the edge of the speed gear, you're going to see those angular cuts also. So when this vehicle is fully engaged, when it's actually achieved full engagement and they slide together, what's going to happen, those two angular cuts will actually pull themselves together. Okay, so if I turn this in this direction and turn this in this direction, because they're angular cut, they're going to draw towards each other. Okay, it's called the torque lock feature. The torque lock feature maintains sleeve engagement with the speed gear. Over time, that little diamond cut may actually wear off of here, or you get into a situation where maybe the blocker ring went bad, you drove it too long, and you actually damaged the little teeth. You'll lose that little diamond cut, and now you got a tendency for these things to pop away from each other. So if you got a vehicle that's popping out of gear, I take a real close look at these diamond cuts. I take a real close look at the sleeve, make sure the sleeve's not broken. I also take a look at the fork, make sure the fork pad is in good shape. A lot of times you get a little clearance in your fork pad and this thing will pop out. But all those things should be looked at if you got a vehicle that pops out of gear. The blocker ring, when that fails, it typically causes a grinding, maybe a tough to get into gear. Those will need to be replaced. But if you physically damage this, it just needs to be replaced. Okay. Other things they talk about in the book, this is what they call a dual cone synchronizer. Just like in an automatic transmission, if you increase the amount of surface area across the clutches, you get a little bit more longevity out of them. So this is a dual cone synchronizer. You'll see that this cone itself will spline directly to the speed gear, and then you'll have a loose cone in here, and then you'll have obviously your outer ring or your outer blocker ring. This increases the surface area, so it's making this machined, or excuse me, this wear surface greater, and then what it does is it causes this this assembly to last longer. You sometimes will find these in truck transmissions, in the second gear only synchronizer, because that's one that tends to wear out. So sometimes you'll take a tranny part and you'll have a single ring synchronizer through all gears except for second. Second gear may actually be a dual ring synchronizer. So be aware of that. Okay, the next part of this book talks about power flow. This is through a Borg-Warner transmission, and it shows you how the power flows through it. You guys can go through that. The only thing I want to point out on this, which is really important, is fourth gear is a 1-to-1 ratio, and the way they achieve 1-to-1 ratio is by locking the input shaft to the output shaft. That achieves a 1-to-1 ratio. Everything else is going through the counter shaft, going through another gear, okay, except for fourth. Fourth is going to be a 1-to-1. So fourth gear is basically going to be the quietest gear in your transmission. It's going to be 1-to-1. You're literally using the sleeve to lock the input shaft to the back of the shaft, and it's complete 1-to-1. Now, in transaxle applications, you'll very rarely get a gear ratio that's 1-to-1. And the reason for that is they're always passing through gears. Just by the engineering of a gear, we typically do not give a 1-to-1 ratio. Okay, we're always going to have kind of a funky ratio, but in a rear-wheel drive configuration, we can achieve it because we're locking the gears together. And that's one of the things that differentiates a front-wheel drive versus a transaxle versus a rear-wheel drive, is that 1-to-1 ratio. Okay, shift mechanisms, they go through the different shift mechanisms. They go through the gates. We already talked about this. In this particular case, you got first, second, third, fourth, fifth, and it looks like reverse is down here. I will tell you, in most manufacturers, they're really concerned with you dropping from fifth directly to the reverse. So there's usually what they call a 5R guide in the transmission. And this is part of the selector assembly. And what it does is it prevents an unintentional downshift from fifth to reverse. So what they'll do is they'll actually put a blocker in there. So if you come out of fifth and try to go straight down, it'll actually push you over to fourth gear operation. The only way to get into reverse is to actually come over the crossover across the selection, then come across, backdrop into reverse. You can't go directly from fifth to reverse in most of these engagements. Some vehicles you got to push down on the shifter, pull up on the shifter. There's a locking mechanism because they typically don't want you to jump in reverse from fifth if you do a manual downshift. Okay, so again, reverse lockout. They talk about that in the book. Make sure you understand that. Again, shifter strategy. This is a 6-speed, first, second, third, fourth, fifth. And then you come over to fifth, or to reverse, you got to come over, and sometimes you actually got to push the shifter down to get over here. It's kind of a tough gate to kind of make a mistake. So if you're in sixth and you try to downshift, you're probably going to find there's going to be some sort of locking mechanism preventing you from getting reverse. You're actually going to go from from sixth right to fifth. So, okay, so there's a lot of engineering in that. This is the detents we talked about earlier. The shift rails, and they're simply a spring with a ball and a little pocket in the rail. So when you put this in a particular gear, that spring gets pushed down on the rail and kind of holds it in there for you. So that's kind of how that works. Okay, and then so on. Make sure you read through the rest of this book. We are going to get into a little bit of serviceability. I'm going to try to get a video maybe today or tomorrow, maybe even next week. Try to get you a little bit more of how you would take these apart. It is very mechanical. It's pretty straightforward. A series of snap rings and pulling operations to take the transmission apart. They do talk about bearing types, which we've already covered in a couple of the other classes and lectures. But they do talk about fluid, all kinds of different types of fluids out there. All I can tell you here is make sure you use a manufacturer recommended fluid, and check your fluid level. There's usually not a dipstick on a manual transmission vehicle. There's usually some sort of port on the side. Sometimes there's a little fastener you remove, and you add the fluid to that fastener hole. You overfill it, it'll drain out, so don't watch that. Very, very common agricultural applications. You got a good old boy, he's got a four-wheel drive truck. Very, very common to see something like this is where he's gone out mudding on the weekends and he actually got water in the vent tube or water in one of the seal areas and actually added water to his transmission. And that water, unfortunately, will get blended with the oil and cause all kinds of rust and contamination in here. So, that's really one of the things you got to watch out for if you have a manual transmission vehicle. unlike an automatic transmission vehicle, we have a dipstick. Manual transmission vehicles, you typically don't, and the fluid level's not checked a lot. So not a bad idea if you got a car that's a manual transmission and you've never changed the fluid. Maybe you bought it used. Go ahead and drop that fluid, especially if the guy's a four-wheel driver and maybe he's sunk the thing a couple of times. But you'll get some rust in there. I've actually heard of so much water getting in a case that it'll actually freeze in the wintertime and crack the case. Very, very common in your marine applications, in your outdoor, your lower units, and some of your outboards. So, again, going through this, I'm going to get this loaded up, these videos loaded up. I'll send it out to you. Should be 3 of them I'll send to you, and hopefully you get to watch all 3 of them. And then I'll do one on a little bit of service. Hope you guys are safe, stay good, and be safe. We'll talk to you. Bye.